welcome to one more home labs tutorial on the Arduino Uno. In this tutorial, we'll be controlling a servo motor by using a tactile switch, and the position of the servo will be updated on a I2C LCD. To execute all this, we'll be using pin change interrupts. So here we go. Here we have a tactile switch, and the tactile switch is rigged up to trigger a pin change interrupt on the Arduino Uno. Now the Arduino Uno has a set of positions saved as an Arduino array, and every time the interrupt is triggered, a value is picked up from the Arduino array. The position picked up from this Arduino array is returned to the servo using the servo.write position command. This command is available in the servo library of the Arduino Uno. And once this is done, the position that is attained by the servo is updated on the LCD. So we have a nice interactive project to do, and through this we'll be learning a number of concepts. So here we go. Here's our setup. We have a 9-volt adapter for powering the MB102 breadboard power supply, and we have a separate 5-volt adapter for powering the Arduino Uno. The breadboard power supply is going to power the servo MG996R and the I2C LCD. Do note here that we have made a separation between the power to the control circuit, that is the Arduino, and the power to the servo and the LCD. This will be more clear in the following screens. This particular servo that we are using uses voltage in the range of 4.8 to 6 volts. So we are powering it using the 5-volt supply available from the MB102 breadboard power supply. The servo has 3 outputs: the orange, the red and the brown. The red one goes to 5 volts, and the brown one, which is connected to this white wire here, goes to ground, and the orange one goes to pin 11 on the Arduino Uno. You are free to use any other pin also, and it is through this pin that the Arduino Uno will be writing the desired position to the servo. The tactile pin, as we discussed a short while earlier, is connected to pin 8 of the Arduino Uno. The Arduino Uno is rigged up to watch for pin change interrupts on pin 8. So pressing the tactile switch basically triggers the Arduino into action. Now we move on to the connections of the I2C LCD. Here we have 4 terminals. The purple one goes to 5 volts, the brown one goes to ground. These are the power supply terminals to the I2C LCD. In addition, there are 2 more connections: the SCL, which goes to A5, and SDA, which goes to A4. The SCL is colored in blue, and the SDA, we have used a green cable. In addition to all this, there are 2 more important concepts that I would like to talk about. So you can see here that there are 2 wires, the red one and the white one. So these wires, what these are doing is that they are connecting the ground on the right of the screen to the ground on the left of the screen. So when the MB102 breadboard power supply is connected to the breadboard, it basically creates 2 power rails, and we want to make sure that both the power rails are on a common ground. In addition to this, you can see this green wire sneaking here. So this green wire is connecting one of these grounds to the ground pin of the Arduino. This means that the control circuit as well as the power circuit both share a common ground. It's very important to do this, and if you forget this step, it's possible that the circuit doesn't work as planned. So here's our code snippet. The first line is include AVR interrupt.h. It's a good practice to include this library in case you are using pin change interrupts. The next is the line to include the liquid crystal library, which enables us to use the I2C LED. Then we have the servo.h library. We do have a nice tutorial on use of the liquid crystal library and the I2C LCDs, and the link to that will now appear on the top right of the screen. The I2C LCDs that we are using has the address of 0x27. You would need to do address scanning to figure out the address applicable in your case. Typically it's 0x27 or 0x37. Then we declare a servo object called servo motor. This servo object comes from the servo.h library. Now we have connected the servo to pin 11 and the pin change interrupt is pin 8. So these variables are there to track the pins 8 and pin 11. Then there are two Boolean variables, run and allow. These are volatile variables because these are going to be changed inside the pin change interrupt. The purpose of these variables will be clear when we look at the code in the interrupt section of the program that we are writing. So run is basically a variable that is tracking whether the motors are running or whether they are at rest position or 0 position. And allow is a variable which enables us to either let the pin change interrupt happen or to skip the pin change interrupt. It's basically letting us take cognizance of the pin change interrupt or to ignore it. So when the pin change interrupt is basically an interrupt which can track a transition, but it cannot distinguish between a high to low and a low to high transition, and using this variable enables us to make this distinction. For more details on this, there is a tutorial on use of pin change interrupts, and the link to that is there in the description box and as well as on the top right corner of the screen. Here are two variables, angle and step. Again, the purpose of these variables would be clear when we have a look at the code of the pin change interrupt. So the various positions that we want to cycle the servo through, these are saved as an Arduino array. Note that these values for this particular motor need to be between 0 and 180, and there's no need for these values to be evenly spaced at 30-degree intervals. I've just kept this as a demonstration to make the demonstration more clear. That's all. Then there are these three variables. So these three variables are useful in displaying the status of run status on the LCD as well as the current position of the servo. The use of the integer no steps would be clear in the following steps of the code, which we shall explain. So here you can see that the run status and this display to how it's playing a role in displaying the value on the LCD screen. So here's our setup loop. We start off by clearing all interrupts. We attach the servo motor to pin 11 and we write the value 0 to the servo motor, that is we bring it to rest. So you can see here that the initial value of angle happens to be 0. Then we use the internal pull-up resistor of the Arduino to set the pin 8 to high. So here no number of steps. So what we are doing is that we are taking the size of the Arduino array and dividing it by the size of the first element of the Arduino array. So this step basically gives you the number of elements in the Arduino array, and this we shall be using in the pin change interrupt vector. We then have these set of lines which are basically used to configure the pin change interrupt on pin 8. There's a detailed tutorial on pin change interrupts, the link to which will appear on the top right of the screen as well as in the description box. There's a set of code to initialize the LCD screen. It's being initialized, the backlight is being turned on and the LCD is being cleared. And the net result of this set of code is to type this out on the LCD screen. Run status equal to off and angle equal to 0. Now we move on to the pin change interrupt vector. So here's the pin change interrupt vector. The first line we have bit read pin B equal to 0. So here we are watching the pin B, and if the pin B goes to 0, then this if loop is going to get triggered. Then we have this allow equal to true. This is basically a flag which enables us to distinguish between the high to low and the low to high transitions. We have used the internal pull-up resistor to set the pin 8 to high, and when the tactile switch is pressed, the value goes to low, and so we ought to be watching only the high to low transition. So this allow equal to true, this allow variable is basically a flag which is letting us distinguish between the high to low and the low to high transitions. So once the high to low transition has been triggered, then this allow is set to false. So it makes sure that when you return back to the high value, the interrupt is insensitive to it and the code here doesn't get executed. So what the code here is basically doing is that it's reading the value from the Arduino array where we have stored a list of angles, and that is getting updated to a volatile variable, and this variable in the void loop we'll be using it to write values to the servo as well as to the LCD screen. So we'll understand this piece of code, this if loop, in a little bit more detail. So what's happening here is that we have an integer array here, and this array, as I explained earlier, lists out the various angles through which we are going to take the servo motor. Now if step happens to be 0, then what's going to happen is that run is going to be set to not of run. So if the cycle is starting, like the motor is initially at 0, then angle is 0 and run value is false. So the run value gets toggled to on when the entire cycle is starting. And similarly, when we have reached the end of the cycle, then the run value is toggled to off for the end of the cycle. And the step is incremented. So when you press the button and you are at 0, then you want the value to be incremented to 30. And so the step gets incremented and the next value of 30 gets read. And after this value of 30 is read, the step plus plus makes sure that the Arduino is ready for the next cycle. Now as we go on incrementing the step, we'll reach a stage when we are at the end of this integer array, and till the time that we reach the end of the integer array, what we are going to do is that we want to read the value of the angle and we want to increment step so that we are ready to read it the next time. So if we are at 30, then 30 will be read, the value will be incremented to step plus plus, that is, it will be ready to read 60. And next time that the interrupt is fired, first the value of 60 is read, and then step plus plus is incremented to point to 90 to be ready for the next cycle. Then once we hit this limit, once we have hit this limit of 180, then we want to reinitialize everything to 0. And that's what is happening here. So this gets triggered if this step size is exceeded, and if this is done, then we have to set step to 0. We have to turn off run, that is, run goes from on to off, and the angle gets set to 0. And allow equal to false is basically, I just explained a short while earlier, it lets you distinguish between the high to low and the low to high transition, and this makes sure that the pin change interrupt vector responds only to the high to low transition and not to the low to high transition. And so now we are through the setup loop, we are through the interrupt vector, and now we are going to the void loop, which is going to run repeatedly. So here, if run happens to be false, that is, run happens to be off, that means that the servo motor is to be returned to 0, and we are going to stop the motor. In case run happens to be anything else, that is, run is on, then the servo motor is returned to the particular angle, and once it's returned to the particular angle, obviously this is going to happen only if the value of allow is false, and once this happens, we are going to update the LCD screen using this piece of code. And here we have used a switch debounce. So basically, I've explained in the previous video that when we press these mechanical switches, instead of having a clean transition like this, what we actually have is something like this. So there's a series of transitions here. It's sort of chatter, and by debouncing this, we make our code insensitive to this sort of debouncing. And once we are done through all this, we are ready to take the next interrupt, and so we set the allow flag to true. So we are done with the code. We'll now be flashing this code to the Arduino, and then the results are there for you to see. So here's our setup. You can see that we have used separate power supplies for the Arduino and separate power supplies for the MB102 breadboard power supply. The breadboard power supply is used to power the LCD screen on one rail and the servo motor on another rail. This servo motor MG996R runs on 5 volts, and so we have powered it using the MB102 breadboard power supply. The signal pin of the servo is connected to pin 11 of the Arduino, and the tactile switch is connected to pin 8 of the Arduino to watch for pin change interrupts. So now we are going to press the tactile switch to trigger the pin change interrupts. And when we do that, so you can see that the run status toggles from off to on. Thanks for watching this video, and if you do like this content, please subscribe to this channel and like this video. Thank you.